Hi, let's continue our discussion on challenges in implementing k-means. By the end of this video, you will be able to explain how the optimum number of clusters can be found. In the previous video, we saw how it can be difficult for us to find the number of clusters when we have hundreds or thousands of features. One thing that we can do is plot a graph where the x-axis will represent the number of clusters and y-axis will represent evaluation metric, which we use to evaluate our clusters. Let's say inertia for now. You can choose any other evaluation metric like the done index as well. Next, what we will do is start with a smaller cluster value, let's say 2. So, we will first train the model using 2 clusters, calculate the inertia for that model and finally plot it here. So let's say we got an inertia value of around 1000. In the next step, we will increase the number of clusters to let's say 4 and train the model. Again, we will calculate the inertia of that model and plot it. Similarly, we can increase the number of clusters in each step, train the model, calculate the inertia value and plot the results in this graph. Similarly, we will draw this plot for several different values of the clusters. Now the question is, how can we use this graph to decide the right number of clusters? If you look at this graph, when we change the cluster value from 2 to 4, the inertia value reduced very sharply. Whereas the decrease in the inertia value reduces and eventually becomes nearly constant as we increase the number of clusters further. So the cluster value where this decrease in inertia value becomes constant can be chosen as the right cluster value for our data. Here, we can choose any number of clusters between 6 and 10. We can have 7 clusters, 8 clusters or even 9 clusters. We should also look at the computation cost while deciding the number of clusters. If we increase the number of clusters, the computation cost will also increase. So, if you do not have high computational resources, it is advisable to choose lesser number of clusters. Finally, we have all the knowledge about the k-means. We will now move on to the implementation phase in the next topic.